Alright guys, this is video 3 and I just realized that video 2 cut out on me in the middle of problem 14. I went ahead and finished out problem 15 and 16 before realizing this. So we're just going to, and there's no way to edit a recording, so instead of redoing all of the work, I'm just going to go ahead and start video 3 here, finishing up these last 3 problems. So again, at the end of video 2 I was finishing up number 14 here. And I was saying that, the square root of 1 is 1, and the square root of c to the 6th is c to the 3rd. So we get a nice perfect square here of just c to the 3rd. The denominator, however, stays as the square root of 2b. Well, that means to rationalize it, I need to multiply numerator and denominator by the square root of 2b. Making my new numerator c to the 3rd, which is on the outside, times square root of 2b, and making my new denominator just 2b. And again, that is because 2b, the root 2b times root 2b is the square root of 4b squared, but that's perfect square. It just turns into 2b. So you look here then at c to the 3rd over, or c to the 3rd root 2b over 2b. Don't get overzealous here and try to reduce the 2b's. They are, one's a whole number and one's a radical, so they don't reduce. You do need to check here though to see if the whole number parts reduce, and obviously c to the 3rd over 2b does not have anything that reduces, so you're just done where it was. Alright, problem number 15. With fractions, like I was saying, if they're radicals, fractions, the same rules apply as regular fractions do. So in this case, yes, you can cross-cancel the 7's because they are both square roots of 7, so you can cross-cancel those roots. So cross-canceling this turns this problem into the square root of 2 over 1 times the square root of 1 over 3. I'm going to then just multiply numerators and denominators, and I'm going to get the square root of 2/3, which, again, I like to write as the square root of 2 over the square root of 3. Simplifying this then, I'm going to multiply top and bottom by the square root of 3. My new numerator is the square root of 6, which I know does not reduce because it's just 2 and 3, and my new denominator is 3. Again, once again, do not cancel those because those are not both radicals or both whole numbers. Number 16, again, you should probably try this one on your own and then unpause the video and check to see if you did it right, but I'm going to go ahead and show it here. So one thing a lot of people miss when they do it on their own is that 6 and 4 do cancel. So this could be square root of 3 over 2. And this is kind of gone altogether then. So then again, you multiply numerators and denominators, you get the square root of 9 over the square root of 10. Well, I'm going to notice the square root of 9 right away is a perfect square. So I'm going to reduce that part. And now I just need to rationalize my denominator because the square root of 10 does not reduce. And that should give me my final answer, 3 root 10 over 10. Because square root of 10 times square root of 10 is square root of 100. So, there you have it. Alright, and like I mentioned, the video 3 was technically supposed to be just about this next section, or all about this next section, which you can see here, the next section is called conjugates. So we're going to go ahead and just talk about what a conjugate is and how to rationalize these denominators right now. Alright, so a conjugate is a method, or conjugates is a method used to rationalize the denominator by changing the sign of the denominator and multiplying. And just, I'm going to put a little bullet point here and add this to your notes. An example, if I have the square root of a minus the square root of b, the conjugate of that is the square root of a plus the square root of b. And that's what a conjugate is. Actually, you know what? I'm going to add another bullet point here, over here, and just do another example like 2 plus the square root of 3. The conjugate of that is 2 minus the square root of 3. So you change that middle sign. Actually, you know what? We should add that up here and say that you're going to, by changing the middle sign, and this is if you have a denominator that is a binomial only. The denominator has to be a binomial only, so keep that in mind. So here with 18 over, this is problem number 17, we have 18 over 6 minus root 2. Don't start trying to cancel anything right away, because, again, you can only cancel whole numbers with whole numbers, but you can't even cancel this 6 and 18, because remember, this is actually 6 minus 1 root 2, and all three numbers would have to cancel in order to cancel. So let's not worry about canceling until more towards the end. So we're going to multiply by the conjugate, which means we're going to multiply this denominator by 6 minus the square root of 2, which means then we also have to multiply the numerator by 6 minus the square root of 2. And then you actually end up multiplying, which in the case of the numerator, it's going to just be distributing. You're distributing this 18. 18 times 6 is 108, so I have 108. And then 18 times negative root 2 is just negative 18 root 2. Again, because thinking of negative root 2 as negative 1 root 2, it's really just 18 times negative 1. My denominator then, I actually have to FOIL. Now, this is going to work the same way every time because we're doing a conjugate. Oh my gosh, I've already messed this problem up. I'm sorry. This should be, the conjugate is 6 plus the square root of 2. Sorry about that. So go back there and change that. This is 6 plus the square root of 2, because that's the opposite of 6 minus the square root of 2, which is what I just talked about. What you do with conjugates, change that middle sign. So that makes my numerator 108 plus 18 root 2. So as I was saying, back to the denominator. We're going to FOIL here, and you're going to see something that happens. So 6 times 6 is 36. 6 times positive root 2 is positive 6 root 2. Negative 2 times root 6 is negative 2 root. Sorry. Negative root 2 times 6 is negative 6 root 2. And then negative root 2 times positive root 2 is negative root 4. Well, the way this simplifies so nicely is that, yeah, the 36 just comes down here to the denominator, but then you have this positive 6 root 2 minus 6 root 2 is 0 root 2, so that just cancels. And then minus the square root of 4 is minus, well, the square root of 4 is 2, so your denominator ends up just being 36 minus 2. Which you can then easily simplify. I have 108 plus 18 root 2 all over 34. And then we get back to the, like we were doing with the quadratic formula. If all three of these numbers can be simplified, do so. In this case, they're all divisible by, what, 2? So this is going to end up being 54 plus or minus 9 root 2 all over 17 as your final answer here. So that was the first problem of conjugates. Even I made a few mistakes there, so we're obviously going to go through these last couple. And again, at any point in time, if you want to try these on your own, just pause the video and give it a shot. It doesn't hurt. It's better to try and get it wrong than figure out what you're doing wrong than just listen to me and copy down what I write the whole time. So, problem number 18, again, I'm going to multiply the denominator by the conjugate, which I'll get it right this time, is 6 plus the square root of 3. Middle sign's opposite. 6 plus the square root of 3 is the conjugate of 6 minus the square root of 3. So the numerator I distribute, and I get 2 root 6, and then plus, not 2 root 6, sorry. Darn it, I thought I wasn't going to make a mistake here. 2 times 6 is what I meant to say, is 12. And then 2 times root 3 is 2 root 3. All over, and then again, I'm going to FOIL my denominator. 6 times 6 is 36. 6 times a positive root 3 is positive 6 root 3. Negative root 3 times 6 is negative 6 root 3. And then negative root 3 times positive root 3 is negative root 9. So again, you're going to notice the same pattern here. The first number comes down, so my 36 comes down as part of my denominator. The middle terms cancel out. Positive 6 root 3 and negative 6 root 3 becomes 0. And then negative root 9 comes down here as minus the square root of 9, which is minus 3. I then simplify this into 12 plus 2 square root of 3 all over 33, and then I look to reduce, but in this case 12, 2, and 33 are not all divisible by the same thing, so I can't reduce. I'm just done right here. So again, even this part, which seems confusing, isn't that extremely difficult, because you're just multiplying and canceling things for the most part. It's called rationalizing the denominator because in simplified form, you're not allowed to have a radical in the denominator. So, again, you should really try 19 and 20 on your own and then check to see if you're doing it right. But you need to do that by pausing the video. So, here I'm going to go ahead and do 19. If you want to do it on your own, pause. I'm going to multiply top and bottom by negative 4 minus the square root of 8. Again, I'm just changing the middle sign, not both signs. Negative 4 stays a negative 4. It's the minus square root of 8 that changes. So you went from negative 4 plus square root of 8 to negative 4 minus the square root of 8. That is the conjugate. A little bit more difficult multiplication here, maybe not. 2 root 5 times negative 4 is negative, trying to get myself some room here, negative, well, we'll just do this right here, negative 8 root 5. 2 root 5 times negative 8 is negative 2 root 40, which again, that's a little bit different from our numerator than what we've had before. So that's my numerator. Denominator, I'm going to FOIL again. Negative 4 times negative 4 is positive 16. Negative 4 times negative root 8 is positive 4 root 8. Positive root 8 times negative 4 is negative 4 root 8. And positive root 8 times negative root 8 is negative root 64. Or, it's just going to turn into negative 8. So again, denominator, we know how that's going to simplify. Let's talk about simplifying the numerator. The square root of 40 is probably the only thing here that I'm going to need to check to see if it reduces. 40 is 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So yes, this will reduce. That pair of 2's comes out as a 2. So my square root of 40, or in this case my negative 2 square root of 40, this is going to have a 2 come out, right, and a 10 stay on the inside, so this is actually going to end up being, for my new numerator, negative 8 root 5, and then I'm going to have minus 4 root 10. and then we know that how the denominator simplifies. You have this 16, these two cancel out, and you have minus 8. Well, 16 minus 8 is 8. And then again, look at your whole numbers here. Negative 8, negative 4, and 8 are all divisible by 4. So I can simplify this down one more step into a final answer of negative 4 root 5 minus 1 root 10 all over wait, what am I dividing these all by? I'm dividing all these by 4, aren't I? If I'm dividing all these by 4, this shouldn't be a negative 4. It should be a negative 2. And then 8 divided by 4 is 2. So negative 2 root 5 minus 10 root 2 for number 19. Alright, last one. Number 20. The conjugate of root 3 plus root 6 is root 3 minus root 6. So root 3 minus root 6. You're going to see me do some shortcuts here in this one, which I'm fine with as long as you're getting these problems right. 2 times root 3 is just 2 root 3. 2 times negative root 6 is negative 2 root 6. Denominator, root 3 times root 3 is positive 9, or I'm sorry, is positive 3 because it's root 9. Root 3 times root 3 is the square root of 9. But I'm going to go ahead and simplify that square root of 9 into just 3. I know my middle terms are going to cancel out, and they're going to cancel out because I'm going to get root 3 times negative root 6 is negative root 18. And then root 6 times root 3 is positive root 18. Well, those canceled out. And then my last term is root 6 times negative root 6, which is going to be negative root 36, or just minus 6. So again, as you start to learn these patterns, you can skip some steps here and do some shortcuts. I'm going to simplify a little bit. 2 root 3 minus 2 root 6 all over negative 3. And since nothing cancels there because the 2's and 3's aren't reducible, you're done right there. So again, this really is not that tough of a section. You need to practice these problems, obviously, so make sure you're doing your homework before you take your practice quizzes and exit quizzes, and get stuff done on time. This is a short section, short chapter, really, short Unit 11, only 3 sections. So go ahead and get working on the homework.